So we'll be creating a trig identity, and I'm going to start off with 1 equals 1 because our identity has to be equal. And from there, I'll be using tan squared x equals tan squared x. And this identity is a double angle trig identity, and that is because they involve trig functions of double angles. Now, looking on the left side, tan squared x can be changed to sine squared x over cos squared x, which is a quotient identity. And a quotient identity is an identity that defines the relations for tangent and cotangent in terms of sine and cosine. Now I want to get rid of this denominator, so I'm going to multiply both sides by cos squared x. And that leaves us with sine squared x equals tan squared x times cos squared x. Now looking on the right side, tan squared x times cos squared x can be changed to tan squared x over secant squared x using the identity cos x equals 1 over secant x. Now looking on the left side, sine squared x can be changed to 1 over cosecant squared x, which is a basic trig identity. So next I'm going to add sine squared x to both sides. And that gives us 1 over cosecant squared x plus sine squared x equals tan squared x over secant squared x plus sine squared x. Now our final equation becomes 1 plus 1 over cosecant squared x equals tan squared x over secant squared x plus sine squared x, and that is our identity. To solve our trig identity, we are going to work with the complicated side, which is the right side over here. So first we are going to express the equation in terms of sine and cosine. So we can change tan squared x to sine x over cos x using the identity tan x equals sine x over cos x. We also have to square this because tan squared x was a double angle identity. Next, we are going to change secant squared x in the denominator to 1 over cos x using the identity secant x equals 1 over cos x. We once again have to square this too because secant squared x was also a double angle identity. So after we have expressed the equation in terms of sine and cosine, we can start to simplify the identity. So first we are going to start by simplifying the numerator and then the denominator, and this will be saved for the last part. So to simplify this, we have to expand the exponent inside the bracket, and we're going to do this by using the rule AB, AC, and BC. So this is the rule we'll be using to expand the exponent. After we have applied the rule, this is what we get. So you can see that is now sine squared x and cos squared x. Now for our denominator, we also have to do the same thing we did with the numerator, so using the same rule, and then that will give us 1 over cos squared x. Now once we have simplified the numerator and denominator, this is what we have over here, and together it's going to look like this: sine squared x over cos squared x over 1 over cos squared x. and this is how it looks together. Now to simplify this, we have to divide, and we're going to be using the rule a over b over c over d equals a times d over b times c. So basically we're going to put this equation into this form. So after we put the equation into the form, this is how it looks, and basically how I got that is by putting it into the equation. So this over here was our a, this was our b, this was our c, and this was our d. Now we can also simplify this, so what we can do is cross out cos squared x, and that leaves us with sine squared x. And remember from our original equation there's also plus sine squared, so we can also do that here. And this gives us 2 sine squared x. Now 2 sine squared x is equal to 1 plus 1 over cosecant squared x, and therefore our identity is true.